Hello everyone, thanks for your patience. Just wanted to say welcome to our Azure 123 webinar series. Today we'll be covering disaster recovery as a service and Azure Backup. So I know we have Simon on the call with us. He wanted to welcome everyone to this series, and we'll be giving you, I think, a good overview of what Azure Backup can do for you, as well as disaster recovery through Azure services. So my name is Joe Griffith. I'm a solution architect with Netrix, and I've got some contact information here on the screen for you if you're interested in reaching out to me after this. We will have a short Q&A session after the conclusion, so if you have questions, we'll be able to address those then as well. So let me quickly go over our agenda with you. Today we'll be looking at basically what is the difference between backup and disaster recovery. In addition to that, we'll talk about how we can actually leverage Azure services to provide a solid backup solution for your environment, as well as disaster recovery. One of the nice things of the disaster recovery solution is it can also be leveraged to do a migration from on-premises into Azure. So we'll talk a little bit about how that can happen as well. So first off, let's talk about backup versus disaster recovery. I know there has been a lot of different confusion and opinions about what a backup can provide versus disaster recovery. Some folks actually believe that they're fairly equivalent. And while they are similar in some ways, it's a very important distinction to understand what is different about these two. So backup itself is not the same as DR because a backup gives you a point in time for your files and your data to go back to. So this is a snapshot in time to go back to restore from if you have a deletion, corruption, if you should unfortunately get crypto locked, something along those lines. You have a point in time preserved of the state of the data or the files that you can turn back to. So that's what a backup provides. Disaster recovery is different in the sense that it's not necessarily about the data so much as it is about your live services that you'll be accessing. So a DR solution is going to let you cut over from a broken environment to a replicated one that's been pre-staged and ready to go and has ongoing replication, so that if you have an outage, you can cut over to your alternate location and pick up from there and continue your services. A DR solution doesn't give you the point-in-time restore, however. It's replicated data. So if you have any sort of deletion or corruption, that's going to get replicated to your DR location. And that's why it does not give you a point-in-time restore. As you see here on the slide, we give a couple of questions that we present to kind of think through this process. So if a user were to delete a file off of a file share or an email from their mailbox, it really wouldn't be advantageous to restore the entire file server or the entire mail server just to get back that deleted item. That's what a DR solution would turn to. And that's not really the best way to handle this. It would certainly give you the outcome in the end, but it would take far more time than some of the options we'll be presenting here, and certainly not as agile. With disaster recovery, similar state, if we have a true disaster like, say, a flood, power outage, anything like that that would impact an entire location, then the backup approach would really involve shipping your tapes or your storage or wherever you have your backups located to an alternate location, and then start the lengthy process of rebuilding the infrastructure and restoring the data. That also is not going to be a very effective method of getting your site up and running quickly, whereas the DR solution we'll show you today can take mere minutes. So let's start off with talking about Azure Backup itself. I'm sure everyone's aware that there's definite necessity for backup and for disaster recovery plans. So we'll go over some of the highlights here that we've seen in the past with issues that can happen with backups and with not having a solid disaster recovery plan. Clearly, there's going to be an impact to the business because there'll be downtime associated with the inability to access that data. Your brand itself might even take a hit if it's something that's publicly viewable or if it becomes a press event. And ultimately, it can also impact the IT careers of those involved. So definitely a lot of importance around the impact of not having a solid plan for your backup and for your disaster recovery. Let's look at a traditional approach to how this might be handled today. So what we have here on the screen is an example of a SQL server, a virtual machine. This could be an application, a file server, anything like that, and then also file shares that go with that. Now, these don't necessarily have to be in Azure or another cloud service. These could be on-prem. The example we're showing here happens to be leveraging Azure storage, but this could be your local storage, file share, SAN, something similar. The concept still holds true. So as you set out to do a backup for these on a daily basis, you'll likely have some custom scripts that may be involved with your SQL servers, maybe the application servers, the file shares themselves. You may or may not, but if there are, then you would have to shim that in here between the server and the actual backup job that's happening. So for SQL, we could leverage SQL native backups. They'll be written to storage. A VM, if it's a hypervisor that you can do a snapshot with, and that can be taken off to storage. If it is something a little more specific to your hardware, you might have a snapshot ability of some kind, but that's being managed manually is the point, and that's being written to your storage. Same thing with file snapshots. You may have the ability to capture an entire file share, maybe through a file sync or another utility, and that's being run on a regular basis and saved to storage. So this is one approach we might be taking today traditionally. An alternative approach is going to come up in just a second, where we'll actually talk about using backup software as well. In either case, you have to manage this infrastructure. So the IT pros involved are having to manage those custom scripts if there are some in these cases. The backups themselves, scheduling those, troubleshooting them when things go wrong. The storage, expanding the storage when it runs out of space, monitoring it, all those sorts of things that come with managing that sort of an environment. That means there's really no centralized management involved. So this is a bit of a burden to maintain and takes a lot of time and troubleshooting when things go wrong. Another option we might have, same scenario with the SQL Server, the VM, and the file share, is you may have backup software already in place to kind of help with some of that load so it's not quite so manual. The backup software then is going to handle the backup jobs from your database tier, from the VM, from the file share, and it will give you somewhat of a centralized management point having the backup software, but there is still quite a bit of infrastructure that the IT pro has to manage. So the backup server itself will have some ongoing maintenance, the storage that goes with it, the troubleshooting, proper scheduling of the jobs, and so on. So a lot of that work is still present there, even if you have backup software in place. Still a good solution and better than nothing, but we're going to show you today how we can really streamline that. So transitioning that over to how Azure Backup would handle it, this is a quick diagram to sort of show you what the Azure Backup service is providing for you. Now, in our example here on the slide, these are VMs in Azure, so they simply require a backup extension. But for your on-prem services or even servers that are another cloud provider, it's very easy with a small agent that gets installed. It accomplishes the same task. At any rate, your VMs or servers will be sending their data into the Azure Backup service. And the Azure Backup service is going to handle everything you see here on the screen, the recovery point management. It's going to communicate back and handle the recovery point management. The schedules that you set, it'll on the back end handle the storage expansion, so you don't have to deal with that manually. Anything else that's going on with your policies as far as retention, so if there's any data pruning involved past a retention point, that's all handled automatically, does not require any intervention from an IT pro that is familiar with that environment. And then Azure also handles your authentication mechanism, access control, and then the reporting that comes along with it. So all of that is canned and provided for you as a service. Makes it really easy to just drop in an agent, configure your policies, and let it run. Another great advantage of using a scenario like this is as your enterprise environment scales up and grows in size, the Azure Backup environment can scale out to accommodate. That's not so easy to accomplish with an on-prem solution or manual, as we saw with the backup software or just manual scripts and so forth. That's not quite as easy to accomplish. Here with Azure Backup, you don't actually have to do anything. It automatically scales to accommodate what you need. You simply add the agents when you need them, and the rest is taken care of. So there's no infrastructure to maintain in that case. It scales at an enterprise level. It's definitely extensible and gives you that centralized management piece that you really need to have when you're talking about backing up your data. I'm going to jump over now and talk about Azure File Sync. This is a relatively new offering. I'm not sure if any of you are using this today, so quick little background if you're not familiar with it. File Sync is basically a means of taking a replica of an existing file share you have, whether it's on-prem or in a cloud provider, and it replicates a copy of that file share into Azure storage. This gives you a secondary copy of your data via a replication mechanism without having to stand up an entire server to host it. So with this service in play, that has now been added into Azure Backup. So you can simply select that file sync if you have it from a drop-down list in the portal and specify that you would like to back up this entire file share in Azure Backup. Because remember, the file sync is giving you a live replica, but it's not giving you a point-in-time restore. So as we talked about with backups, we need to have a point-in-time restore for a safety mechanism. So Azure Backup will allow you to select your file share to establish a retention policy that you'd like to have and how frequently you want this backed up so that you can go back in time to some sort of a schedule that you're comfortable with, whether that's on an hourly basis, daily basis, however you like to configure it. You're in charge with those types of policies. So it's a policy-driven approach. You define the policies you want for backups. It has a user-defined retention, so you get to define how long you want these to be retained. And it provides a file level restore. You don't have to bring back the entire share, in other words. You can restore individual files off of here. In addition to these, we also have the ability to back up Linux applications by installing a small agent within the Linux operating system. So that's done by providing access to the server and installing the agent that's required. When the backup kicks off, there is the option to have a pre-script that can run any commands you might need to manually address before starting the backup. A snapshot is then taken of the VM, and then there's an optional post-script step if you need to do any scripts afterwards as well. The incremental backup is then saved into the backup vault. So this is a theme with Azure Backup. It does an initial seed, and then it's only the deltas beyond that. So you can restore from multiple snapshots in time. We'll look at that in a little bit. Also, I'll have a demo to explain that to you a little bit better. So when the Linux backup is being run, this lets us back up any Linux application because it will quiesce the application data and then allow you to take that snapshot and establish a point in time to restore from if you need it. Something else that's relatively new is what is called a restore as a service. This is the ability to take the backed up data in Azure Backup, and it can be mounted as an iSCSI target and presented to your VMs in Azure. So this gives you the ability to browse a volume that's attached to your VM, look at the data that's there, and then basically copy from one drive to the next. So you get basically an instant restore capability by having this in place. You could also go through the restore service traditionally, but this is a little bit faster and also gives you the ability to inspect the data before you restore it. So in some cases, this might be more ideal depending on your needs. Zero infrastructure involved. You simply go into the Azure Backup service as it exists and state that you want to mount this volume as an iSCSI target, and then you present it to your VM and go from there. You'll see a volume of files where you can copy from and put them wherever you like them to be. So I think we've covered that pretty well. Let me talk about some of the different ways that Azure Backup can be utilized. So there is Azure IaaS Backup itself. This is the integrated backup capability in the Azure portal. So when you're looking at a VM in Azure, there will be a button you can click to simply enable the backup for that VM. There's a schedule that's in place that runs on a time that you decide and define with a retention that you define. But you can also do a one-off at any point by simply clicking a button in the portal. No infrastructure required. You simply configure Azure Backup and it takes it from there. Another option is called Azure Backup Agent. So this is meant for an on-prem solution where you might have just a simple file server or something that needs to have flat files backed up. Simple deployment, an agent is installed, protects any flat files, and as of fairly recently, also system state, but it does not protect application workloads. That's not the intent of agent. We have an option for that in just a second. The reason that this is attractive is it's a quick agent install, and from there, the native backup software simply sees Azure storage as a target, and you can schedule backups as you would normally do with a local backup. You might find this to be helpful in the case where you have a file server that has files you'd like to back up without building out an entire infrastructure to do so. It can also be used in some scenarios where, say, for example, you might have a VIP or executive management that has a desktop or laptop where they like to keep their files locally, maybe on the desktop, maybe somewhere that is not necessarily in a shared location where the rest of the data is stored in the company, and you want to make sure that their data is getting backed up successfully in case they needed to have something restored. This is a quick and simple way to do that. Let's say you have a C-level executive that is using a laptop while traveling and has a lot of files that are on that specific device and nowhere else. You could use this agent to back up that data across any internet connection and keep your restorability intact for that user. The third option is Azure Backup Server. Now, I have here or DPM in parentheses. If you're not familiar with DPM, that's the backup component of the System Center suite. It stands for Data Protection Manager. For those that have System Center licenses, they can use DPM. If you don't have a System Center license, you can use Azure Backup Server. They are 99% the same. Azure Backup Server only differs in the branding that's in the title bar and the fact that it does not support tape libraries. But otherwise, it is basically the same DPM if you're familiar with DPM. If you're not, that's quite all right. Very nice backup solution that will look at your local servers, whether they're physical or virtualized. It will take copies and retain them locally, just like a traditional backup solution would. You get to define how much time is used for that local cache. Let's say, for example, 2 weeks. So if you have a local cache of 2 weeks of data and you need to do a restore within that time frame, it's already local to you. You can quickly restore from on-prem. Anything beyond that is spooled off into Azure for offsite backups. And if you need to restore from that point, it would simply have to download the data first and then you have the restorability. So there's a little bit of ramp up time to get the data back on-prem so you can do the restore, but you do have that offsite capability. You can do away with tapes. You don't have to have a complex infrastructure, and this gives you a really good solid solution. This will let you back up any Microsoft workload, the system state of servers, pretty much anything you would do with typical backup software on site. So the server itself is included in the cost of doing Azure Backup. So you can have as many servers as you need to have. The billing is based on the number of instances and how much storage you're using, so you can deploy Azure Backup servers in your environment wherever you need them to be. So talking about system state backup, we can do this with just Azure Backup Agent alone. We can also do it with Azure Backup Server. System state is going to capture the key components of an individual server, whether it's just a core Windows server or whether it has an application installed. So that's going to be things like the registry itself, the COM+ database, so you can bring back the state of that server. If you have applications installed, it'll include the configuration components of those applications, such as Active Directory, certificate services. If it's in a cluster, the cluster information that's associated with it. And if you're running IIS, the metabase as well. The really nice thing with using Azure Backup Agent is you don't really need to have an infrastructure in place, just this agent alone. So if you're doing a system state backup of a server, you can write directly into Azure Backup Storage. The way that works is you download an agent from the portal, install it on your server, and then you schedule a job that runs maybe on a daily basis, and that system state is then sent into Azure Storage directly. Nothing else is involved. This makes it really quick and easy to get this deployed. It's cost effective for offsite backups because you're not having to manage an entire backup infrastructure to do it. You get the same server protection for file servers, AD, and web servers that you would get with a backup solution because you have that system state that's being sent up. Again, this is for flat files, folders, system state. The backups themselves are secured. They're actually compressed and encrypted before going into Azure. And this gives you the same single management pane in Azure that we've been talking about throughout all the Azure Backup products. So when you look at this from the Azure side, everything is in one place, whether it's Azure Backup Agent, Azure IaaS Backup, or Azure Backup Server. You look at all of them together, configure the policies together, and the retention. Next, we'll talk about some hybrid deployment models. This is where we'll introduce Azure Backup Server. This could also be Azure Backup Agent if you're just doing files and system state, but primarily we're focusing on Azure Backup Server here. So let's look at a primary data center that's on-prem. You'll typically have some databases, we'll say SQL. You may have an Exchange server or servers, same with SharePoint, and some other application servers or file servers that are present. In remote offices, you'll probably have a smaller footprint there, likely some file servers, maybe an Active Directory domain controller. We have suggested here a read-only domain controller just for example purposes, but it can really be anything that you have out in your remote offices. Azure Backup Server can back up Hyper-V VMs, as well as VMware VMs, and also any physical servers that you have. We do that by dropping in Azure Backup Server into the on-prem location. And again, if you have DPM, you could use that in place of it. That server will then be configured to look at your servers both in the primary location and any branch offices you have. We can configure those to be backed up into Azure Backup. Again, Hyper-V VMs, VMware VMs, doesn't matter, physical as well. It will collect the data, keep a local cache available to you that you get to define, push it across the internet to Azure File Storage. Now, the biggest problem with introducing any new backup solution is that initial seeding of data. There's a large amount of data that you have to get into the offsite location initially. You might consider doing this over the wire if it's feasible to get your data in a reasonable time frame, but if we're talking a large amount of data, you need another option to get it up there quicker. So out of the box, you can back up several terabytes of data right out of the product and send it across your internet connection, because the Azure Backup services are going to compress that data. And we see usually about 30 to 40% reduction in size when we do that. That alone might be adequate enough for your environment or for your individual servers to send this into Azure Backup Storage. However, if you have way more data than you're willing to push across the internet connection, we have some options to look at for getting your data seeded offline. You would do that through procuring 10 terabyte disks or up to 10 terabytes and putting the data on these disks. These would then be secured with BitLocker so that they're encrypted, and then they're physically shipped into an Azure data center. Azure uses what's called an import service that will allow you to bring this data in, mount it up into your backup vault, and you have complete control over how that's handled and when it's done, and you actually pull the trigger on restoring it. But this gives you the ability to transfer large amounts of data offline. Definitely save in network bandwidth and in time. In addition to offline seeding with drives, there is a new service that's in preview right now called Azure Data Box. This works in a very similar fashion, but instead of using individual drives, Azure will actually ship you an appliance that you locate on-prem to where you want to copy the data from. And you take all of the data that you're looking to transfer in an offline fashion, send it in multiple streams to this data box. It can hold up to 100 terabytes, so a lot more capacity in this device. And then that device is shipped into Azure. Same process from there. The advantage with this is you don't have to procure all those different disks, and you can do parallel transfers with this. Same safe and secure method that we use with the drives. This is encrypted and secured and sent into a highly secure data center for restore. When you're deciding where to locate your backup vault, you can pick from any geographic region in Azure. So we're showing you a map as it looks today. This is always expanding and growing, so definitely check and look back at this as time goes on and see if there are any new regions that interest you. But you can pick any one of these locations to store your backup vault data. You can have multiple vaults in a given region, and you can have vaults in multiple regions, wherever you need them to be to help you out. So with that being said, I'll show you a quick demo of doing the Azure IaaS VM backup. Give me a quick second to flip screens. And I'll show you a lab environment that I have here. I have what I'm calling on-prem VMs. And this is actually a demo environment. It's actually in Azure itself, but for purposes of this, we'll pretend this is an on-prem environment. I also have a Azure location for this fictitious company. This is located in the East US, and this is where we'll do our Azure IaaS backup demo. So let me show you how that works. I'm going to pick one of the VMs here. We'll look at VM1. If you're not already familiar with using Azure, this is what's called a blade that has information about this particular VM that's running. On the list here is a backup option. By clicking here, I get access to all the backup controls for this VM. It's asking me which backup vault I'd like to use. I have one already here. It's called East US for the region that it's in, and RSV, which stands for Recovery Services Vault. That's what we call a backup vault in Azure. If you have multiple vaults, you can pick the correct one from the list here. Then you define your policy. There's a default policy to help you get started that runs daily, but you can define whatever policies you like. For example, I have one here that runs at 2 a.m. every day. It has a retention period of 7 days of dailies, 4 weeks, 12 months, and 10 years. I'm going to pick that one. I simply click on Enable Backup, and a job will now kick off that's going to reach out to that VM and provision it for backing up. Once that's in place, we'll have the ability to do ad hoc backups at will, as well as restores. So rather than sitting and watching this run, I have a VM that's already configured that I'll show you so you can see what that looks like. So let me switch over to VM number 2 and go into backup. Now this is after the backup agent has already been pushed out and configured and provisioned. This is what it will look like from there. We get some quick stats on our VM. It tells us the last backup status, whether it was a success or not, the vault that it's in, the policy we're currently using, and then also the oldest restore point. Down here I see a list of the snapshots that have been taken. This will be important when it comes time to restore something from this VM. If I wanted to do a one-off backup outside of the schedule, I would simply click Backup Now. It gives me the ability to define how long I want this one-off backup to be retained, and then I hit OK. It's as simple as that. A backup will now be scheduled in the background on that VM, and a new snapshot will be taken. If I wanted to restore from this server, I'd simply go to Restore VM, and from here I'd pick the restore point I'm interested in, and then proceed through selecting what I want restored from there. It's a pretty straightforward and easy interface. There's also a file recovery option where you can mount up the volume and look at the individual files and bring them out if you like to do it that way. So it's as simple as that to set up an Azure IaaS backup solution. Let me pick back up on the slide deck and we'll move on to our next topic. And that would be disaster recovery using Azure Site Recovery, or ASR as we like to refer to it as. Like we talked about with backups, there's definitely going to be an impact to the business anytime you have a disaster recovery event. Backups are bad enough if you lose data or files and have to struggle to get them back. But with a true DR event, we're talking about a major impact to the business itself and its continuity. I'm sure we've all seen plenty of things in the news and headlines about different companies that have gone public and fallen to whatever mishaps occurred, whether it's natural or some sort of a break-in attack, crypto locking, various different things like that. These things do happen. What's important is that we plan properly for them so that we can recover as quickly as possible. Some quick stats before we get into the technical part of it. Forrester did a analysis last year, and they found that there are 18% of companies that said they were very ready for a DR event, which is a pretty shockingly low number. I'll actually read here what they quoted. Only 18% of global disaster recovery decision makers and influencers feel very prepared to recover their data center in the event of a site failure or disaster. That's a pretty shocking number, and what we'd like to do is show you a good way to handle that using Azure Site Recovery. They found in their analysis that a lot of the difficulty with having a solid DR plan was a lack of preparedness, insufficient core planning processes, or out-of-date plans, and limited testing. And truly, DR planning and testing is difficult to do manually. It takes a lot of time and effort, and by the time you get through it, the environment may have changed enough that you kind of have to restart some of those processes. So it makes it very difficult to stay on top of this, have a solid solution, and all along meeting your compliance needs as well. As you know, DR events can be caused by a variety of things. Forrester found that the system failure category accounted for 56% of those failures. Other different things can come into play, such as power failures, natural disasters, and even cyber attacks. And usually it's a combination of a couple of things. So in the case of a natural disaster, you may also have a power failure and a systems failure. So that's why the percentages tend to overlap here a bit. The cyber attack is one that's definitely gaining momentum, and we should be ready for that, both with Azure Backup and Site Recovery. This number is only going to rise with time. Some of the challenges that companies reported running into when they're trying to establish a good business continuity or disaster recovery plan is, first and foremost, definitely cost. So that cost is represented by a lot of the manual effort and man hours involved with managing that solution and trying to find a way to make sure the data is protected for the company. The complexity that comes with that. Again, if the environment changes, then your plan also has to flex with it. And a lot of these things take a lot of time manually to put together, so that's where the cost and the complexity really can be a deterrent for people to stay on top of a good, solid plan that's workable when you need it. And then compliance needs as well can also be a hindrance to having a good, solid plan, because it's difficult to make sure that your data is handled correctly in both locations when you have compliance needs in way. So how can Microsoft Azure help you? Well, using Site Recovery, we can leverage an environment that gives you an automated way of failing over and a simplified way of doing tests. By doing that, we can reduce the costs, reduce the complexity involved, because you're not having to do as many manual steps. They don't take nearly as long to come across with a solid plan. And that, of course, leads to increased compliance, because now you're able to meet those compliance needs. So as we look at recovering into Azure with Azure Site Recovery, the compliance is improved. It's easier to onboard. We'll show you how simple and direct that can be. And there are a lot more features available in doing a failover with ASR than you would probably have normally. Some of these screens here you'll see in more detail in a minute when we do our demo. And there's other features we can talk about as well. So ASR itself, it's a pretty straightforward solution, but it has many different implementation scenarios. So we've got a few of them spelled out here so you can see what it looks like. I'll start off with scenario 1. This is Hyper-V to Hyper-V on-prem. And what's interesting about this is there's no actual failover into Azure being involved here. ASR does not necessarily expect you to fail into Azure. It's a service you can leverage that will help you orchestrate and coordinate a DR failover between 2 points. You get to define what those points are. They can be 2 on-prem locations. It could be on-prem and a different cloud provider. It can be on-prem and Azure. However you need it to be. So in this case with scenario 1, it's an on-prem Hyper-V replica, but this gives you a globally accessible service where you can go to trigger that failover. Scenario 2 is the same thing, but in this case we're using SAN-to-SAN replication to bring down the RPO. For scenario 3, it's Hyper-V to Azure. If you're not using Hyper-V, that's okay. Scenario 4 covers VMware and physical. This takes a little bit more infrastructure and planning to set up, but the steps and the end result are the same. And then finally, the fifth scenario is using VMware and physical to Microsoft Azure. So let's jump ahead and we'll talk about some of the different advantages that we see with using ASR. It gives you an automated VM level replication. So your VM itself is being replicated into Azure. What's actually happening is the disk from the VM is being replicated from on-prem into Azure, and then when a DR event occurs, you simply boot up that VM and use it. This gives you an RPO of seconds and an RTO of minutes. So definitely advantageous. Here's one of the great things I love about ASR. No impact DR drills with test failover into Azure. I shouldn't say into Azure, it's test failover into your secondary site, but I'm going to show you today a demo where it is going into Azure. So you're able to do drills, see how your DR plan works, and actually test it out without impacting production. You can do both planned and unplanned failovers. A planned failover will try to reach out to the original source, get one last copy of the data before it fails over, and possibly even shut down that VM. With unplanned, it assumes it can't get to the original location and simply turns on the last replica that it has and goes from there. The entire process is orchestrated using what's called recovery plans. We'll get into that in just a little bit, and we'll show you how those work. But they work like a runbook. There's also failback support. So once you've failed over, if the original issue in the primary site has been resolved, you can actually fail back the VMs back to where they were. You can truly migrate to Azure from anywhere. It can be on-prem, it can be another cloud provider. Wherever you have an internet connection and your agents installed, this can be set up. It's also helpful if you just need to make an on-demand test copy in Azure for development purposes, QA, etc. This gives you that ability. And as we'll see in a second, since ASR is replicating your VMs from on-premises into your secondary location, such as in Azure, that actually presents a migration option for you. We'll talk about that as well. So I'll quickly go over some of these and we'll get into the demo so you can see how this works. So as we said, ASR itself sits above your two locations and provides orchestration and coordination. In the case of the multiple tiers like you see here, you might have a SQL availability group getting from one site to the other. You might be using ASR replication. You might be using native application replication like with Active Directory. However it's being handled, if you don't have application layer replication, ASR can replicate the VM for you. ASR is compliant with many different standards, and this is just a short list here to give you kind of a quick highlight. There's a link at the bottom for the Trust Center. If you've not visited that, I would encourage you to have a look and look at all the different compliance and security standards that are on that list. It's quite extensive. So as a quick diagram to do a disaster recovery for Hyper-V, we already have the VMs and is a perfect state for Azure. Since Azure itself runs in Hyper-V, the disks that go into Azure have to be Hyper-V disks. So coming from Hyper-V is the easiest. We simply send the data over a secure channel using either the public internet or an express route connection if you have it. Azure Recovery Services Agent will handle the replication of the data. And once it's there, we can simply turn on that VM. Now for VMware or physical servers, it works in a similar fashion, but we need an interim process to get transition from the physical drives or from VMware's disks into a Hyper-V disk. So the ASR portal access gives you a download you can leverage that will install multiple roles on a single VM that is responsible for handling all of the conversions of the VM from either physicals or from VMware. Actually converts it on the fly to a Hyper-V disk locally, and then it replicates that Hyper-V disk into Azure, just like the Hyper-V scenario did. So there's some infrastructure and planning involved to make that work, and the core takeaway of that is it converts it to a Hyper-V VM and then lets you replicate that into Azure just like we did with the Hyper-V solution. Then from there you can turn it on and work. Now, in the case of having to fail back, we can reverse this process where the Hyper-V VM is replicated back down to on-prem, and then it can be reconverted back to VMware. It's not really possible to convert it back to a physical, so once a physical server has been converted, it comes back as a VM. So let's do a quick demo using ASR. I'll switch over here to my pretend DR site. I have configured a recovery services vault already. So this has a few VMs being backed up and replicated. You get some nice data charts and diagrams here to tell you how it's going, how the process looks overall, as well as a diagram of the infrastructure. So I can see here that in my primary region, I have 4 VMs being protected, utilizing a storage account. They're replicating over to my recovery region into the site recovery vault. So let's have a look at some of those VMs. I can see here an example of 4 that I already have protected and in place. What I'm going to do is show you how we'll set up the protection for one of those initially, and then we'll actually do a quick failover. So I'm going to pick one of the servers here. We will look at, let's take this one for example. So as the server has been replicated into Azure, what we see is a couple of different things we can configure in here. There's first off a failover button and a test failover button. If you look over here on the side, you'll see a warning that says I've never successfully performed a test failover. ASR will highly recommend you do a test failover before you rely on a true DR event, just to make sure the process works. You don't have to do it, but you'll see this warning unless you've done it at least once, because that's a good idea to do. Before we do any failovers, we want to look at how it's configured. This gives us some basic stats on the VM itself that we're looking at. Under Compute and Network, we get to define how we want the failover to take place. So this column will show you your on-prem VM as it is today. Here's the name of it. We're going to fail over to the exact same name, but if you wanted to rename it on the fly, you could. In Azure, we have a concept of a resource group. If you're not familiar with that, it's a way of collecting resources together. I have one here just for demonstration purposes. This is telling what the on-prem size is. It's 1 core, 3.5 gigs, and 1 NIC. So it's going to find the closest match in Azure. Since these are technically in Azure, it's an exact match. But for your true on-prem servers, it'll find the closest match in here on this list. And if you're not happy with that, you can drop this down and pick any size you want. So you can effectively scale it up or down on the fly as well. If you need to, you can configure which network the NIC will attach to and whether it's static or dynamic. In addition, you'll see a list of the disks that are in that VM. If for some reason you wanted to skip some of them, you could omit them from the replica. Once that's started, you'll see, I'll do a quick test fail over here so you can see what it looks like. We'll run this command. It's going to ask us what recovery point we want to pick from. So keep in mind, there's an ongoing replication job right now taking place. And we can pick from the most recent point in time to do that restore. We'll typically put this into a test VNet so we can test it without impacting production. This is the key to doing a successful test without hurting the production environment. We're assuming here that the production network has some sort of connection back to your on-prem location. So we don't want to create any DNS confusion or any other network traffic that might interfere with the real environment. So we have a separate, isolated test VNet just for that. We'll hit OK here, and the test failover is in progress. It'll take maybe 3 to 4 minutes. It will start setting up the services and the different components that go with that. Rather than waiting that out, though, let me show you what that looks like after it's done. So here I have a VM that has already concluded the failover piece. In this state, we have a VM up and running in Azure with the exact same name. Of course, it has a different IP address because it's in a different VNet. So DNS will replicate that change out to the environment for us. Before we're completed with this process, we're going to look up here and notice there is a commit button. This exists because if we wanted to, we could change to a different recovery point using this button here. Let's say we stood this up and realized this didn't go back far enough in time. We need to go back older. We could pick from an older recovery point if we'd like to. Once we're satisfied we have the correct one, we would hit commit, and that makes the change permanent and gets rid of the replica. This now becomes the primary copy. Once that step is complete, we would use reprotect to start replicating this back to on-prem, because at that point, this VM is the one and only copy running in Azure. Reprotect lets you restore your ASR replication by reversing it back to on-prem. So if you have to fail back, you only have to copy the last data and then switch over. I'll also show you quickly, I'm kind of jumping ahead a little bit here, but I know we're running short on time. So there is a slide about doing a migration. The nice part about that is once you've done the replica here into Azure, you've already completed the steps for replication. There's a button that will appear to complete the migration step, and it will simply destroy the replica copy and stand up this VM as a permanent transfer without the expectation of failback. So a migration is basically half of the ASR process with no expectation to fail back. So let me jump back over here to our slide deck and see if we have anything left to cover that I didn't hit in the demo just now. Obviously, replicating Azure VMs in Azure is an ideal scenario because it's coming from Azure to Azure. So ASR not only works with on-prem, but as we said, it's any 2 points. You may have some servers or VMs that were built in Azure to start with, and that's perfectly fine. ASR has a mechanism for doing what we call A to A, or Azure to Azure, with ASR replication. It's important to consider this. Many people miss this point. When you build a VM in Azure, that VM exists in one region, and the data that is stored with that VM could optionally be replicated to a secondary site, but the VM itself is not. So if you had a DR event, your data might be replicated, but you would have to quickly stand up the server, attach it to a VNet, attach the public IP, the NSG, all the different components that go with it, and then boot it up. Whereas with ASR, it already has all that done for you with ongoing replication that you don't have to touch or manage. You simply flip the switch and the last replica comes online. You route traffic to the secondary site and you're done. So it's important to realize that even if your VMs are in Azure, you will still have a need for site recovery or some method of having a DR solution. So what I want to show you quickly before we wrap up and do QA is something called recovery plans. So let me go back over here to my recovery services vault. And I'm going to scroll down here to recovery plans. This is the actual runbook that's involved with failing over. So I'll show you a quick example of this so you can kind of get the idea of it. But you build multiple groups in this runbook. So let's say you have 5 servers in here that represent a given application. You can dictate, for example, that there is a group that starts the SQL databases first, and then it moves on perhaps to the application tier. And then perhaps it moves on to another set that you need after that. So you get to define the order that these come up in, and each group completes before it moves on. You can have a recovery plan for a specific purpose or application. You can also have a recovery plan for the entire site, and servers can belong to multiple recovery plans. So you could have servers A and B in an application failover, while servers A and B are also in the entire site failover. And when you have a DR event, you can come in here and pick whichever recovery plan is important to you. Whether you're failing over an application that's failing, maybe the site itself is fine, but the application is broken, so you can fail over those services. Or if you have a true DR event of your site, you could fail over everything in that site with the orchestrated failover in the order you decide. What's also really helpful is that at any point in here, you have a pre-action and a post-action you can specify. The pre-action can be a script that you run, or it can even be just a manual step. You can put whatever name you want for this and specific instructions such as get verbal confirmation from the CIO, for example. And this will actually pause here if it's a manual step and wait for you to click a button to say I completed it. You can do this both before and after failover steps. So this gives you a lot of different options for both testing your failover and doing a real failover event. When you have manual steps like this, there's an additional box that appears for you to add notes to that to indicate anything you might want to note about this particular step as it occurred. And as I said, with migration, it's really what we just saw with failing over with ASR. You just simply don't fail it back. So with that, I'll just open up quickly to any questions we might have from the group and see if anyone has anything they'd like to the benefit of all.
Hey, Joe, can you guys hear me? Can you guys hear me?
I can hear you, sir.
Excellent, thank you. And sorry, I had some audio issues at the beginning. Thanks so much for people joining. We are monitoring the IM box as well, so if you have any questions, please either come off mute or I think we've got something from Tim coming. While we've got this time as well, I would just let you guys know that this is a series of webinars. The next one will be on Tuesday, next Tuesday, I believe. And I'm just, let's have a look.
Simon, I've put a slide up here. We've got one coming up on the 17th, it looks like.
Correct. I think we've got a question there, Joe, from Tim. I don't know if you can see that in the IM window. If we have a backup solution product, i.e. Commvault, that's already paid for, can that work with Azure as well? In other words, just like Azure is the landing spot.
So that's an interesting question. In that particular case, it would depend if the product itself makes Azure storage available as a destination target. If they do, then you could simply leverage your storage and have that written to directly by Commvault. You could alternatively also use Azure Backup. In some cases, you'll have to make sure that you don't run into an issue with the VMs themselves thinking that they're backed up and then being flagged for a full sync. So there's a couple of tricks that sometimes have to be done when you have two backup products like that. But I think what you're asking is, can you send it from Commvault into Azure Storage? And the answer to that is you can if the backup product provides that as a proper destination for you.
Commvault is one of our partners, as is Veeam, so I know that there is options there to use Azure as part of that solution. And Tim, you can feel free to reach out to any of the team directly. I'll just drop my email address into the window here. So if you want to talk further, we can. We will be doing follow-ups. I would also just remind people that the minimum monetary commit for Azure is just $100 a month, so $1,200 a year. You can kick the tires on some of this. So put some VMs in to back up and some of the rest of it. And again, your licensing provider should be able to help that. If not, there's my email address there, and happy to run through that. We did post what you get for $100 a month from Journey to the Cloud on the www.azure123.rocks website. But again, feel free to reach out to me directly, and we can do some work with Joe and Christina and ourselves. We've got a couple more minutes. There's no other questions. Again, thank you for spending some time today. We hope it's been useful. Look up some follow-up emails, and look forward to seeing you guys next week at noon.
Great, thank you, Simon. We've got just a couple minutes left here, so I'll be monitoring the IM window for any questions you might have. And thank you for the clarification with Commvault and Veeam, definitely partners of ours. I just wanted to kind of state it in a generic fashion. So as anyone else on the call is considering the same question for their backup product, ultimately it is determined by whether or not that product allows you to send to Azure. In the case of Commvault or Veeam, they do. So no worries there. Guys, I realize you may not have questions right away necessarily, but as Simon said, feel free to reach out, send us questions later if you think of them or something comes up and you'd like clarification. We're happy to help you out.
There's also pots of funding that we as Microsoft can apply for to help do some of that heavy lifting on some of that project work. Thanks, guys. I think that's it. This recording will be posted, and look forward to seeing everyone next week.
And as everyone departs, just want to give you a quick reminder, you'll be seeing a follow-up email for a survey of this presentation. We look forward to your feedback and comments as well. Thank you, everyone, for attending. Have a great week.